আজকে আমরা গিগনার রিএজেন্ট ব্যবহার করে 1 ডিগ্রি 2 ডিগ্রি 3 ডিগ্রি অ্যালকোহল বানাবো এবং কম্পিটিটিভ এক্সামের জন্য কিছু প্রশ্ন উত্তর ডিসকাস করব। তোমরা অনেকেই হয়তো শুনেছো নিউক্লিওফিলিক অ্যাডিশন রিয়াকশন। এই নিউক্লিওফিলিক অ্যাডিশন রিয়াকশনের মাধ্যমেই গিগনার রিএজেন্ট বিক্রিয়া করে। তাহলে নিউক্লিওফিলিক অ্যাডিশন রিয়াকশন কি? এটা হলো এমন একটা বিক্রিয়া যেখানে নিউক্লিওফাইল গিয়ে অ্যাড হয়ে যাবে কিন্তু কোনো লিভিং গ্রুপ বেরোবে না, সেটাকে আমরা বলবো নিউক্লিওফিলিক অ্যাডিশন রিয়াকশন। 1 ডিগ্রি 2 ডিগ্রি 3 ডিগ্রি অ্যালকোহল বানাতে গেলে আমাকে এই বিক্রিয়ার হেল্প নিতে হবে। প্রথমে একটু বুঝে নিই গিগনার রিএজেন্ট সেটা কোন মাধ্যমে কাজ করে, যেটা খুবই ইম্পর্ট্যান্ট অংশ। সবসময় গিগনার রিএজেন্ট ইথার মাধ্যমে কাজ করে। কখনও যদি কোনো অ্যাক্টিভ হাইড্রোজেনযুক্ত কোনো সলভেন্ট যেমন অ্যালকোহল, অ্যাসিড, ওয়াটার এগুলো থেকে থাকে তাহলে কিন্তু আমার গিগনার রিএজেন্টটা অ্যালকেনে রূপান্তরিত হবে, অর্থাৎ যে পারপাসে ব্যবহার করছি সেই পারপাসটা ফুলফিল হবে না। যে কোনো কার্বনিল কম্পাউন্ড সেখানে সবসময় কি থাকবে? সি ডবল বন্ড ও। এই কার্বনিল কার্বনের কার্বন লেস ইলেকট্রোনেগেটিভ তাই ডেল্টা পজিটিভ, অক্সিজেন মোর ইলেকট্রোনেগেটিভ ডেল্টা নেগেটিভ। গিগনার রিএজেন্ট যখন RX ছিল, গিগনার রিএজেন্ট প্রিপারেশন করার আগে একে যখন আমরা Mg ইথার দিলাম তখন মজার একটা ঘটনা ঘটলো যেটা তোমাদের জানা উচিত। এখানে R দ্যাট ইজ CH3Cl ফর এক্সাম্পল, CH3 delta positive, but when magnesium inserted in this molecule CH3 converted to delta negative because magnesium is more electropositive and we get a nucleophile called R minus. For example, in this reagent it is CH3 delta minus. This CH3 delta minus nucleophile add to carbonyl carbon, form an adduct. How this reaction occur? Delta minus, that is R delta minus, which act as nucleophile, attack to carbonyl carbon. This bond shifted towards oxygen and a adduct formed O minus. This one R, which is added from Grignard reagent. This is another bond. Adduct or addition compound. Halo magnesium alkoxide, we may call this one, because here magnesium and halogen also added to this adduct by ionic bond. That's why it is called halo magnesium alkoxide or addition compound or simply an adduct. When dilute HCl is added for hydrolysis purpose, OMgX converted to OH and magnesium salt MgOHX or MgCl2, MgBr2, like that. In the hydrolysis step we may use dilute HCl, dilute H2SO4 or sometimes, particularly for 3 degree alcohol preparation, aqueous NH4Cl. Now come to 1 degree alcohol preparation. For 1 degree alcohol preparation we use mainly formaldehyde, that is HCHO. Formaldehyde, when treated with methyl magnesium iodide, which is a Grignard reagent, in presence of dry ether solvent, we get an adduct HCOMg counterion of Grignard reagent, that is MgI, OMgI, and this one hydrogen, new alkyl group added from Grignard reagent. It is CH3, so we write CH3 instead of R. The molecule formed is CH3 CH2 OMgI, CH3 CH2 OMgI, which on hydrolysis produce CH3 CH2 OH, CH3 CH2 OH, that is primary alcohol, because OH group attached carbon is directly attached with one methyl group. We should remember in this reaction ROH is converted to RCH2OH. So we may use this reaction to prepare next higher homolog or step up reaction. ROH first converted to RX then RMgX. Finally, RMgX react with HCHO to form higher homolog RCH2H. For example, we may show CH3OH, red phosphorus I2, CH3I, Mg ether, CH3MgI, formaldehyde HCHO, CH3, we must use ether, CH3, CH2O, MgI, hydrolysis step, dilute HCl, CH3, CH2OH. From methyl alcohol to ethyl alcohol using Grignard reagent, step up conversion. Very important. In future, we learn using KCN, CH3I added KCN converted to CH3CN, then reduction CH3CH2 and H2, then HNO2 alcohol. There is another pathway, but you should learn this pathway. Maybe ABCD type question asks. So you should learn every possible ways. For NEET and JEE purpose, question may ask methyl magnesium iodide plus oxyren. It is also called epoxide compound. CH2, one oxygen inserted between two CH2 group. This type of oxygen prepared from ethylene using paracid. CH3MgI plus oxygen, what happened? Now this Grignard reagent alkyl part which act as nucleophile added any one side of CH2. This bond open to form O minus where the counter ion of Grignard reagent added by ionic bond formed CH3, this one, CH2, this one. Now this bond is open, again CH2 OMgI. After hydrolysis, when we added dilute HCl, we get CH3, CH2, CH2OH. So what happened? In this reaction, we may increase 2 carbon at a time using Grignard reagent. If we use trimethylene oxide, then 3 more carbon atoms increased in this reaction. Try it in your home. Preparation of 2-degree alcohols. 2-degree alcohols, when OH group attached carbon directly attached to another carbon is called 2-degree alcohol. For example, CH3, this one hydrogen, isopropyl alcohol is 2-degree alcohol. So 2-degree alcohol can be prepared by the reaction of Grignard reagent with any aldehyde except formaldehyde. Why any aldehyde except formaldehyde? Because aldehyde group when attached with methyl group or RCHO group, R group is already present. So one alkyl group is directly attached. Grignard reagent when added to this carbonyl carbon, another alkyl group add to this carbon. Now we get 2-degree carbon because 2 directly attached alkyl group is present in this carbon. And C double bond O converted to OH. So finally we get OH group added carbon directly attached to another more carbon. So it is 2-degree alcohol. That's why instead of formaldehyde, if we use any other aldehyde, it form 2-degree alcohol. For example, we take acetaldehyde. When acetaldehyde react with methyl magnesium bromide in presence of ether solvent, the compound first formed is CH3 attacked to this carbonyl carbon, O minus formed with counter ion MgBr, Mg plus, this CH3, this one, here it is hydrogen. Now we get the skeleton structure of 2-degree alcohol because when we hydrolyze this molecule using dilute HCl, this part is converted to OH. As a result, we get CH3OH. Here one hydrogen is attached. This is called isopropyl alcohol. Isopropyl alcohol. If we use methyl magnesium bromide, then we get this product. When we use ethyl magnesium bromide, what happens? In ethyl magnesium bromide, you should know that this carbon is delta negative because it is directly attached with magnesium, not this one. So this carbon act as nucleophile added to carbonyl carbon in nucleophilic addition fashion. So we get CH3, this one, C, this one, O, MgI, hydrogen, CH2, CH3 comes from Grignard reagent. Now dilute HCl. This portion is converted to H. We get CH3, CH, CH2, CH3 and this one OH. Butane to all. 2-degree alcohols can also be prepared from ethyl formate using 2 moles of Grignard reagent. Sometimes in competitive exam asks you how many moles of Grignard reagent is used in this reaction. So what is ethyl formate? Ethyl alcohol and formic acid, when mixed together in presence of concentrated sulfuric acid, it form an ester called ethyl formate. Ethyl formate, when react with Grignard reagent, methyl group added to carbonyl carbon, this portion open. So HO minus, which converted to OMgBr, O C2H5, this one CH3 comes from Grignard reagent. Now automatically 2 oxygen never directly added to carbon, always remember, because lone pair repulsion occur. So automatically this negative oxygen revert back and remove this OC2H5 group. So we get ketone H. Here we get aldehyde CH3, and this aldehyde again treated with methyl magnesium bromide, we get 2-degree alcohol CH3 COH CH3, here 1 hydrogen. This one comes from Grignard reagent, this one also comes from Grignard reagent. That's why 2 moles of Grignard reagent is used. Substituted oxygen react with Grignard reagent to yield 2-degree alcohols. In primary alcohol preparation, we learn that when oxygen react with Grignard reagent, alkyl part, nucleophilic alkyl part, may add either side of the oxygen. But now attack occur less crowded center, because in this oxygen molecule one carbon is substituted by methyl, so this portion is sterically hindered. R minus attack less crowded portion. Automatically this bond open up and formed CH3C. This carbon directly added to oxygen because this side is broken and converted to OMgI. 1 hydrogen is here, CH2, which is now free from oxygen, and CH3. After hydrolysis, dilute HCl, it is converted to CH3 COH CH2 CH3, 1 hydrogen is here. 2-degree alcohol using oxygen. Preparation of 3-degree alcohol using Grignard reagent. Always 3-degree alcohols can be prepared using Grignard reagent when we react with any ketone. Ketones means R double bond O R. Already 2 carbon is directly attached with this carbonyl carbon. Grignard reagent supply one another R group, and finally the molecule is converted to R3COH if all R's are similar, identical. If different, then R prime, R double prime, R triple prime, this type of alcohol may form. Any one of the R comes from Grignard reagent. For example, acetone, when react with methyl magnesium bromide, always put ether solvent, because otherwise Grignard reagent converted to alkane and loses its function. Delta minus attack to carbonyl carbon to form an adduct by nucleophilic addition reaction CH3, C, CH3. This one comes from Grignard reagent, which is circle. For better understanding, never circle in your exam, just for understanding. This is an adduct. When dilute HCl or ammonium chloride, aqueous ammonium chloride treated, the hydrolysis occur and we get CH3 whole 3, this one, this one, this one, that's why whole 3, COH. Tertiary alcohol. Sometimes asks you, prepare 2-methyl propan-2-ol from ketone using Grignard reagent. So this is called 2-methyl propan-2-ol because CH3, C, CH3, OH. This is propan-2-ol. Here one methyl group is also added. That's why 1, 2, 3, 2-methyl propan-2-ol. When written in language, sometimes we are not able to answer. But if asks prepare 3-degree alcohol, we may answer very easily. For your better understanding, practice these problems as homework. 2 different alkyl group containing ketone and methyl magnesium bromide treated with this molecule. So this portion added, open up, converted to OMGBr. Finally we get, after hydrolysis, H3O plus, first one ether, we get CH3CH2, C, CH3, OH, and comes written in another color. This portion comes from Grignard reagent. Here 2 alkyl group are different. Grignard reagent alkyl group also different. So we get tertiary alcohol where R prime, R double prime, R triple prime, this type of tertiary alcohol. 3 alkyl groups are different. CH3CO is to CH3, CH3CH2 MgBr. This CH3CH2, this portion delta negative. This carbon attack to carbonyl carbon form OMGBr, and finally we get CH3COMGBr, written already present alkyl group. Then write Grignard reagent alkyl group, that is here CH2 CH3. Practice makes perfect. Always practice this reaction so many times, otherwise it is very difficult to understand. For competitive exams, sometimes it may ask that ethyl acetate or ethyl ethanoate when treated with Grignard reagent, how many moles of Grignard reagent required? First Grignard reagent alkyl group added to this carbonyl carbon, it open up, formed CH3COMGBr, that is O minus MgBr plus OC2H5. Here CH3 comes from Grignard reagent. This O minus return back, eliminate OC2H5, converted to a ketone whose formula is CH3 C double bond O CH3. This portion eliminate and form alkyl part of CH3 MgBr, that is CH3 added to ketone carbon and converted to tertiary alcohol. After hydrolysis, it is formed tertiary butyl alcohol. Thank you for watching.